Hey guys, this is Levi Woods, and this is Quick Physics, Episode 1. So, since this is a new series, basically what we're going to be doing is just talking about some physics concepts and laws and such that I think are very important and people should learn about, and we're going to try to take the shortest amount of time possible. So today, we're going to be talking about Newton's lug, or law of universal gravitation. I'm too lazy to write it out. And so let's get into it. So the main part of it, and the main part that I'd just like to talk about is, well, the basics of it is that it says that Newton's law says that gravity pulls at a constant rate. So if you had a big rock and then a small piece of paper, they'd both fall to Earth at the same rate, 9.8 meters per second squared. So without air resistance, these objects, if dropped at the same height, would hit Earth at the same time because they are pulled at the same rate. So the more math behind it, though, and the big equation that comes with it, and really the main point of this episode is the law. So it's the force of gravity is equal to big G times m1 times m2 divided by the radius squared. So this G right here is the gravitational constant. This is equal to 6.67 times 10 to the negative 11th. Okay, sorry about that. This r squared is the distance between the objects. Just write big so we don't have enough room for it right there. This m1 is mass 1. This m2 is mass 2. So with m1 and m2, it doesn't really matter which one you label m1 or m2, it's just as long as you've made that distinction. So what this equation can be used for is to calculate the force of gravity on two objects. So if you have a planet and a satellite, or an object and a planet, it's usually something with planets and celestial objects and all that sort of thing. So let's do a quick example. So let's say we have a planet and we have a satellite orbiting the planet at this is its orbit. We have its little solar panels in the body, and we want to know how strong the pull is that this planet is giving to this satellite. So let's rewrite that equation there. So the force of gravity is equal to big G, and let's say that the planet is m1. So we'll have the planet right here is m1, and then the satellite is m2. So let's say the mass of this planet is, let's say it's 100 kilograms. So we'll do 100 times, and then let's say that this is 5 kilograms. 100 times 5 divided by the distance. Let's say it's about 1,000 meters. So we have 1,000 squared. Okay, so let's plug this in our calculator and let's see what we get. So the first thing we do is we turn our calculator on, and we have 6.67 times 10 to the negative 11th, and I just like to keep that as it's a constant, so it's right there. And then we multiply that by 100 times 5, and then we divide that by 1,000 squared. So the force of gravity between these two objects is 3.335 times 10 to the negative 14th. It's a very small number because, well, these are very small objects and very small masses that we're dealing with. So this equation can be used for, and is used for, things such as calculating the force of gravity between objects, like a satellite and a planet, and it can be used for many other things. I hope this video was helpful, and I'll see you in the next episode.